We've talked rather vaguely so far about various traits that can be influenced by genes and the environment. We've used the example of height or weight. Most recently, we talked a little bit about personality and criminality, where we're starting to move more towards those psychology-based things that we're all here for. And so in this next section, we're going to continue in that psychology direction. We're going to talk about two of the best studied cases of gene-environment interaction in psychology, which are personality and intelligence. And we're going to start looking at things that are giving us an idea of genetic influences and also environmental influences on behaviors. We're going to start by talking about intelligence and the heredity of intelligence, where we're looking at those genetic factors that might be passed on from your parents that determine your intelligence, or at the very least influence your intelligence. And so we can do some more of that logic, that thought walkthrough that we had done when talking about our twin studies and our adoption studies. And we can have our sort of logical consideration where if we were thinking of intelligence as something that is entirely genetically determined, if all of our IQ was determined by our genetics and none of it was determined by our environment, then people who have the same genes would have equal IQs. Now, this is obviously just a thought exercise. This isn't actually what it is. We know that there is at least some influence of our environment on our IQ. But for this thought experiment, our logical conclusion would then be that if you have 100% shared genes between two individuals, they should have identical IQs. So if you looked at identical twins, then they would each have the same IQ. So we'd have a correlation coefficient of around 1. And logically following, we can look at the idea that parents would share 50% of their genes with their children, so the correlation between parents and offspring in terms of IQ scores would be somewhat less than that perfect correlation between identical twins. And by the same logic, the genetic relatedness between siblings, specifically siblings that aren't identical twins, is going to be 50% as well. So the correlation there between siblings in terms of IQ would be less than, though that you see with identical twins. And that correlation between siblings should be similar to the correlation that you see between parents and offsprings, because both siblings and parent-offspring pairs have that 50% genetic sameness. And so that's our theoretical interpretation of what we would expect to see if IQ or intelligence was genetically determined. Now, I'm sure you figured it out by now, but that's not actually what we see in real life. In reality, the best you can get is genes accounting for about 50 to 70% of the variation in intelligence that we see in populations. So there is still quite a large chunk of our intelligence that is influenced by our environment. And so we can actually look at a table where they've calculated out these correlations between different groups of people to see how correlated their IQ scores are. And so this chart here comes right out of our textbook, and it's going to give us a relationship, so people, how closely related they are to each other, and how environmentally related they are to each other. It's going to give us a little cheat column of the percentage of shared genes, and then it's going to give us that correlation score. So we will start at the top with identical twins. And so the first one is identical twins reared together, and then one right below that is identical twins reared apart. So for both of these cases, we're looking at individuals that share 100% of their genes. They have identical genomes as far as we care. But the twins that are reared together share an environment, and those twins that are reared apart don't share an environment. So we would then logically conclude that any difference in the correlation of IQ scores that we see here is going to be due to either sharing or not sharing the environment. because that's the only part that's changing. And we can see here that, as we would logically expect, identical twins reared together are more similar or have a higher correlation of their IQ scores than identical twins reared apart. So that makes sense. That checks out with how we're thinking about this idea. Next, we can look at identical twins reared together and non-identical twins reared together. So by the reared together, we're saying that they share an environment in both cases. So this time, the only difference that we're seeing is that identical twins share 100% of their genes, and non-identical or fraternal twins are going to share 50% of their genes. So the differences that we see between their correlations is going to be due to that genetic component, due to how much of their genome they share. And again, we see that the non-identical twins, the twins that share less of their genes, are less similar than the identical twins that share more of their genes. Again, following our logical conclusion here. The next group that I've highlighted here are all individuals that share 50% of their genome. So we have non-identical twins reared together, and then siblings reared together, and siblings reared apart. So here we have non-identical twins reared together, meaning that they share 50% of their genes, they're in the same environment. Siblings reared together means share 50% of their genes, share an environment. So these two numbers should be fairly close to each other, which they are. We're still seeing a little bit more similarity with twins, but that's more of a complication of how twins tend to be raised, which is a very interesting topic that I don't have time to go into here. But perhaps if you're interested, we can have a conversation about that at a later date. And then when we have siblings at the bottom here reared apart, that's when they have 50% shared genes, but no shared environment. And we see that dramatic drop off in our correlation scores. So we're seeing the difference between these two, because they both have 50% shared genes. It's whether they share an environment or not. And so by walking through each of these steps, we can kind of pick apart which differences are we seeing because of environment, which things are we seeing because of genetics, and everything seems to be falling out in a nice predictable pattern, which is pretty great. Now, we've logically walked through how genes and environment seem to have a predictable effect on the correlation of traits between people who differ in terms of degrees of relatedness versus degrees of environmental sameness. But how can we actually conceptualize this interaction between genes and environment? How can we kind of wrap our heads around what specifically is going on? And to get at that, we're going to talk about the idea of a reaction range. And so this is going to kind of help us visualize how genes and environment work together to give us our observed phenotype, that final outcome behavior. So when we talk about a reaction range, we're talking about a range of possibilities that your genetic code allows. So we're basically saying that you would inherit a range of potential expression. So if we're looking at IQ, then your genes would say that based on your genetic material, your IQ should fall somewhere between 90 and 110. So you should fall in that range right in the middle of our IQ scores. And then the reaction part says that our environment is going to determine where a person falls within these limits. So your environment can determine whether you fall on the higher IQ end of the range that your genes set out, or if you're going to be on the lower end of that range. And again, as always, for those who are more visual learners, we have an image of this here. And again, straight out of the textbook. So we can look at one of these units here, where this light purple bar in the background is going to be that genetically determined reaction range. That's going to be the space that your genes say that you are capable of falling. So in terms of IQ, this is saying that you would be somewhere between this lower bound and this upper bound based on the genes that you have. Then your environment determines where this actual number, your measured IQ score, is going to fall within that range. And we can walk through some examples here so that you can actually see this in practice. But on this chart here, we're just looking at IQ on the y-axis here. And on the x-axis, we're looking at quality of environment for intellectual growth. What this basically means is, are you living in an area where you have lots of resources, an enriched environment where you'd have access to things that help you be smarter, things like access to books, a good school, a good teacher, lots of attention as a child. And then on the other end of the scale, a deprived environment would be maybe you weren't allowed to go to school, maybe you never saw books, maybe you're in a country that doesn't value education. Those all count as being in a deprived environment. And so here, people can have these reaction ranges, these genetic influenced ranges that their IQ can fall. And we'll look at, let's say, average and enriched and this one person in the deprived environment, because they're all in about the same range, plus or minus a bit, where they're saying that your IQ is going to fall somewhere between, for this person, 110 and 140. And we have another between 110 and 140 here at point E. And then we have a couple over here who are, this looks like 100 to 130 is their range. So that's how you're reading what the range looks like. And then in the deprived environment, you'll notice that a lot of these circles, these measured scores, are showing up at the bottom of that range. So even though their genes said that their IQ could be anywhere between 110 and 140, this person was in a deprived environment, so there wasn't lots of environmental influences causing them to become more intelligent, so their IQ falls lower on that scale. And then if we go over here, in the enriched environment, you can have people who are at the upper end of their scale because their environment allowed them to achieve sort of a higher score, but that score is still within the limits of their range. So even though you're in an enriched environment, your score can't be higher than the upper limit of what your genes set out for you. Basically saying you can't be smarter than your genes would allow. And it is good to point out that not every person who's in an enriched environment is going to be at the upper end of their range. There are going to be some people who aren't. And similarly, you don't have to be at the very bottom of your range if you're in a deprived environment. You can be sort of anywhere along there. But this is saying that overall, people in deprived environments will probably be at the lower end of their range, and people in more enriched environments should be towards the upper end of their range. But as always with populations, there's going to be quite a bit of variability in there. Now, as we move on to talk about personality, I do want to point out that even though we've talked about behavior being a combination of genes and environment, we've already started to see a couple of instances where there are also other individual qualities or other factors that could be going on that affect the interaction between the two. So maybe there was something going on with individual G here that allowed them, so even though they were in an enriched environment, they ended up scoring lower on their reaction range than you would have expected just based on the environment. So maybe there's something else going on there other than just genes and environment. And so we're going to call this other category the unique individual experience. And that's how the textbook refers to it. So we can talk about our genetic contribution, so the stuff we're getting from our genes. We can talk about our shared family environment, so that's your environmental contribution. And then these unique individual experiences is basically the catch-all term for other stuff that's going on. As you move further into psychology, some books will call this error, some books will call this unique experience. It kind of depends. But this is the stuff that doesn't count as genes or environment. So keep that in mind as we start moving into our conversation now about personality, the second type of gene-environment interaction that we're talking about in terms of psychology specific. Now, if you don't know a lot about personality yet, one of the big theories that is most popular right now in terms of psychology and personality is called the 5-factor model. So after statistically boiling down variation in personality, a bunch of researchers believe that they can account for all of our individual differences in personality using just 5 personality traits or scales or dimensions that they call the Big Five. Now, these are our 5 scales here, and they're going to exist on sort of a continuum. So we can use extroversion, introversion, the first of those factors, and we can think of the scale as being a range from someone who is extremely extroverted, who is outgoing, who is uninhibited and social. And then the other end of the scale at introversion is going to be someone who is very introverted, someone who is solitary, socially inhibited, would rather be alone. So you can exist or score anywhere along that continuum from very outgoing to not outgoing, and that is your score for the extroversion-introversion factor. The other factors are agreeableness, conscientiousness, neuroticism, and openness. In case you're interested, agreeableness is going to be a scale from someone who is cooperative and helpful all the way over to someone who's going to be antagonistic and very unhelpful. For conscientiousness, you can range from someone who is responsible and goal-driven, or someone on the other end of the scale who is careless and irresponsible and not responsible towards goals. For neuroticism, we're going to range from being very worried and anxious over to being very calm and well-adjusted. And lastly, for openness, that scale runs from someone who is imaginative and creative and open to experience versus someone who is unreflective and uncurious and doesn't really care about those new experiences. So those are our 5 scales that people can score on. Now, 5 seems like a really small number to try and give us a very full view of human personality, but so far there's been quite a bit of evidence building up to support this theory. And one of the cool things that they found recently is that researchers are finding a link between different personality types, so different scores on some of these scales, and actual physically measurable differences in brain function. So for example, that introversion-extroversion scale will show that people at different parts on that scale have different levels of brain arousal. So you can actually look at brain scans and see differences that correlate nicely with their personality score. So if we have this link between personality and biological measures like brain activity, then maybe there's a genetic factor that's behind this too, which is what we're going to look at in the next couple of slides. To look at this gene-environment interaction, we're going to use what should now be a more familiar setup, and we can look at a combination of a twin and adoption study. So to set this up, we would want to look at 4 different groups. We would have identical twins that had been reared either together or apart, and fraternal twins that had been reared either together or apart. So we would want to look at people who share 100% of their genetic material and either share an environment or don't share an environment. And then we would also have people who share only half of their genetic material, and then again, shared or unshared environment. And that should let us pick apart the gene contribution to this personality score, and also the environmental contribution to this personality score. And we can also start looking at things like those extra traits, those extra factors that don't quite fall under genes or environment. And of course, I'm sure you can imagine that because I've brought it up now, that those other factors, those unique individual experiences, actually play a pretty large role when it comes to personality. So if we look at one study, the Minnesota Twin study, looking at personality, this is one of the largest and best known studies of this kind. They ended up looking at 400 pairs of twins, so 800 different people who had been either adopted or not adopted, and who were twins, either identical or fraternal twins. So this was a massive data set. And they measured a ton of different personality traits, then ran their statistics to figure out the comparative contributions of genes, environment, and unique individual experiences to see which of those was contributing to variation in those personality traits. And overall, they found kind of what we would expect at the beginning: genetic factors responsible for between 40 and almost 60% of the variation in personality. So pretty large genetic influence on variation in personality. But the cool part is the family environment, so whether they shared or didn't share an environment, had little or no effect on personality. So identical twins that were reared together versus identical twins that were reared apart didn't have a massive difference in their correlation scores. And what was cool and what we care about is that their unique experiences, those unique individual factors, what I like to think of as their error term or their extra catch-all factors, that explained almost as much variation as the genetic factors. So there's a large portion of personality that's determined just by how an individual interacts with the world, which I found to be pretty cool. And this table is just a summary of a bunch of the different traits related to personality that they had measured. And we're just looking at this very, very quickly to show that this genetic component ranges between, we have 40 or 0.4, 0.39 is the lowest there, up to 0.58. That's where those numbers are coming from. The unique environment looks about the same, between that 0.36 and up to 0.56. And the cool one being the family environment, where there's between 0, so no correlation with environment, up to about a 0.2, which is saying that there's some degree of environmental influence, but not a ton. So I found this to be really interesting, that the environment plays such a small role, despite all of the conversations we've had about it's the genes and the environment working together, but it's also a unique individual environment. So outside of the home, things that twins, even though they're raised usually together in the same home, probably in the same room, go to the same school, there are other unique factors unique to each individual that they don't share, and those are the parts that make more impact on their personality.